Hi everyone. Today I am going to tell about interference in thin films. So here in thin films, superposition is due to any two reflected rays or any two transmitted rays. So here I have drawn the thin films. So here AB is the thin film. So here the light rays are coming from the source which is incident on thin film. Some of the light rays are reflected on the top surface of the thin film and the remaining rays are transmitted on the lower surface of the thin film. So here AB is the incident ray. So here incident ray can be breaks into reflected rays and transmitted rays. So here the source has given incident ray. So here this is the incident ray and this is reflected ray. BE and DF are the reflected rays and BC and HA are the transmitted rays. So that let us draw normal line HE on the top surface, that is the path BE. So that light is number of reflected rays and number of transmitted rays. So that some portion of light is reflected on the top surface and the remaining rays are transmitted at the bottom surface. So number of reflected rays and number of transmitted rays generated in between the thin film. Like this, incident ray can be breaks into reflected ray. So here also incident ray can be breaks into reflected ray. So that the total path difference P cos R plus T cos R. The light rays are traveling from denser to rarer medium. So that the additional phase difference lambda by 2 can be added to the total path difference. Therefore, the total path difference P cos R plus T cos R. So 2T cos R. So here the refractive index of the thin film, that is mu. So that the total path difference between reflected rays and transmitted rays is 2 mu T cos R. So that 2 mu T cos R plus additional path difference lambda by 2. Therefore, what is the condition for bright fringe? The path difference is equals to n multiples of wavelength. So that 2 mu T cos R plus lambda by 2, which is equals to n lambda. So what is the condition for bright fringe? 2 mu T cos R is equals to n minus 1 into n lambda minus lambda by 2. So that 2n minus 1 into lambda by 2. Therefore, the total path difference is equal to 2 mu T cos R plus lambda by 2, which is equals to n multiples of wavelength. Therefore, 2 mu T cos R is equals to 2n minus 1 into lambda by 2. This is the condition for bright fringe. So, whereas coming to condition for dark fringe. So, 2 mu T cos R plus lambda by 2, which is equals to 2n plus 1 into lambda by